finally glad to see it's getting warm in Missouri. I was worried about the weather. I'm from North Carolina. I was worried about, should I bring a jacket? Yeah, I didn't bring one. But thanks to SEMO for inviting us out. We appreciate you guys and everything you guys do, and appreciate the work you give Pike Electric. We've been part of y'all's team, I think, for a number of years. I remember back, I was talking with Marty earlier about the big ice storm of '09. It's the first time I ever heard of the town Sykeston, Missouri. We got to know it very well during that time. So again, appreciate it. We won't keep you very long. I know it's hot. We got some empty seats up front. It's almost like church, isn't it? Everybody wants to sit in the very back. Scared to death of the church. Scared to death of those front chairs. I'm the same way, I guess. But anyway, I'll tell you a little bit about who we are. We're Pike Electric, based out of North Carolina. Our home office is in a little town called Mount Airy, North Carolina. But we work all over the United States, basically, in some form or fashion. My mic is about as loud as it's going to get. Maybe I can talk a little bit louder. Sorry. These fans just throw my voice around. But we basically work all over the United States in some form or fashion, whether it's through our engineering department, our distribution, our transmission, substation, telecom, renewables. We do a lot of that work as well. Plus we have a fleet operations as well. You see behind us here, this truck that we have here, we have 3 of these trucks actually that run all over the footprint of our service territory. We do a lot of demos for our customers as well as our employees. And the whole reason behind this, how many believes that the electrical industry is a dangerous occupation? Raise your hand. Let's put your hands down. That's kind of a trick question. I like to start with that because I feel that our industry is one of the safest industries they are if it's done correctly. That's anything we do. Think about it. How many of us drove to work today? Every one of us drove here. So driving, in the same analogy, if we start running, if we start speeding, start running traffic lights, don't wear our seat belts, things of that nature, it becomes dangerous. Well, line work is no different. If we start breaking rules and start taking shortcuts, that's when this industry becomes a dangerous occupation. But we're going to show you some things here today that actually makes this work dangerous if we don't, exactly what Ron said right there, if we don't stop, think, observe, and plan our job. I love that message. That's exactly what we got to do as linemen. We got to plan our job. We got to stop and think and observe and plan our job. But today we're going to show you some of the shortcuts that can lead to injury and things of that nature. Introduce our guys on the truck. We have Jeff Rogers. Jeff's from Texas. He brought the Texas heat with him, I think. Jeff's been in the industry how many years? 45 years? 43 years, a long time. We have Willis Porter. Willis Porter's from over in Kentucky. A little bit cooler over there. He's been in the industry about 45 years, is that right? And all that time's been spent right here with Pike Electric. My name's Andy Cleary. I started with Pike in '89, and the last 33 years I've been right here. We enjoy what we do. We all work in the safety department. We all been in the safety department for quite a few years now. And but anyway, today we're going to show you again some of the dangers. This truck, to explain the truck just a little bit, how the truck operates, we basically have a 5 kVA transformer, basically something like what you see hanging out on a pole in your yard. Right now we're on low voltage. You see the cable coming up the pole there, that's our feed. And on the top there, we have some primary wire. Typically that's where your primary is. Your energize phase is typically on top, but some cases it can be on the bottom as well. Matter of fact, one of the requirements of a qualified electrical worker is to be able to distinguish exposed live parts from other parts of electrical equipment. That's exactly what we're doing here. We have the neutral on the bottom. That's typically your current carrying or your return path to ground, your neutral. Then in the middle right there, we have a recloser. We'll talk a little bit about a recloser, how it operates, and if you're not familiar with the recloser, I almost bet you have experienced one in operation. We'll talk a little bit about that as well. We have a cutout at the top there. On over where Jeff's standing, we have some more conductor. We have another 3 kVA transformer. That transformer is going to feed our light on the back of the truck. Also on the back side of that pole there, we have an underground primary dip. We'll talk about the importance of getting locates and things of that nature. We have a red light here, or a green light actually, indicating that our truck is ready to be energized. When I squeeze the trigger, the red light will come on, letting us know that the primary wire is energized, and that light on the back of the truck should come on as well. This is a live line demonstration. We have all our PPE. Now, when we are considering planning the job, as Ron mentioned there, one thing we should plan is how can we eliminate those hazards. That's the hierarchy of control when it comes to, to dealing with hazards. If we can't eliminate that hazard, personal protective equipment is our first line of defense. So that's what we're having to do today. This is a live line demonstration. We have all our proper PPE on. I'm gonna energize the truck. When I do that, the light should come on. You guys ready? Ready. All right. I'd like to introduce a friend of ours. He's a brave bear. He's been through a lot. We don't use live animals anymore. Nah, we never did. But what happens on a good day like today, there's no storms in sight, other than the heat outside. You wouldn't expect an outage, but a lot of times outages can be caused by animals, such as bears, squirrels, snakes, other animals as well. So we're gonna show you what happens when Bobby the bear, is that his name, Bobby? That's a good name. Bobby the bear, he climbs a pole. He gets between two differences of potential, and he causes an outage. There's gonna be a loud noise here, so look what happens when Bobby the bear makes contact. Ready? Coming hot. There we go. Finally. So usually, that's a pretty easy fix for a lineman, isn't it? The customer calls in, they call SEMO, said, I heard a loud noise, my lights are out. You guys dispatch someone out there, and they go out there and they start looking around, they see the cutout on the pole hanging down, excuse me. They may see an animal laying on the side. So it's an easy fix. They refuse the cutout, check all the connections, and close the door. Lights are back on. That's usually a pretty easy fix. So animals can cause outages. Let's go to our recloser. How many of us has been home and our lights go out and come back on, go out and come back on? There's a fault somewhere. As an example, let's say this barricade is a single-phase tap, and it's fed off the main line, but it's also fed off of a fuse tap. There's a fuse behind this tap, and there's a fault that gets on this line, on this tap. What's going to happen? It's going to send a signal, so to speak, back to this recloser, indicating there's a fault on that line. And that recloser is going to open up, then it's going to reclose, hoping that fault will clear up. So we're going to put it through its operation. Normally it happens about 3 times. On the 4th time, if the fault isn't cleared up by then, it's going to open up and stay out. You ready? Ready. Coming hot. So each time that that recloser cuts off and comes back on, it's putting power back on that line, hoping that fault will clear up in time. That time it didn't clear up, so now the line's out. So we'll go back to that recloser here just in a second. If you look around, a lot of businesses have a lot of underground, right? What's that number you call before you dig? 811, right? It works here in Missouri. It works in the Carolinas, Florida, Texas, Washington, wherever you're at, the United States. That number works. How important is locates? You guys, probably just about every day, there's some type of utility being cut, right? Just about every day. There's somebody's calling in, hey, I've cut a service line, I've cut a telephone drop, things of that nature. Matter of fact, I could almost bet we could dig anywhere on this property without a locate and probably cut something. So Jeff is going to simulate a cut cable. That cable he has on his shotgun stick there is an underground primary cable that can have up to 7,200, 13.4, 13.2 volts on it. So it's very important that we make sure we get our locates. Gonna be another loud noise here. Jeff's at home. His wife said, hey Jeff, I bought these trees at Lowe's. I want you to plant these trees for me. And Jeff goes outside with a shovel. He starts digging around. He forgot to get his locate, and guess what happens? He cuts an underground primary cable. You ready, Jeff? Coming hot. Now that's not an easy fix typically, is it? You guys that do line work back there know if it's a loop feed, you know you got to go through there and figure out where the open point is. You gotta isolate this cable. You gotta make sure that open point can tie together. You go back to where the problem is. You gotta stand it off, test it, ground it. Then you gotta spike it, cut into it, then make the termination. It takes a little bit longer than the transformer. Always important to make sure we get our locates. Let's go back to our recloser. A recloser has an option on there. We call it an option or a function, you could say. It's called a one-shot. If you read in the OSHA standard, it talks about reclosers just a little bit. It talks about if you're crossing over lines, if a line crew is working out there and they're crossing over energized lines that are energized over 600 volts, if I'm relocating that cable that's energized or that conductor over 600 volts, I have to make this recloser inoperable. And the reason for that is there's a lot of old conductor out there. If I untie that old conductor and I'm going to take it up 5 more feet and it were to break mid-span and hit the ground, I don't want it coming back on me that second and third and fourth time. In other words, I'm going to put it on one shot. Well, Smokey or Mr. Willis is. See that red handle? That's a one-shot handle. We're going to put the same fault again, like Jeff did earlier, showing that how the one-shot works and operates. You ready, Jeff? Ready. Coming hot. There it is. So that's just an example of one-shot. We do a lot of storm restoration work here at Pike. Matter of fact, we're moving crews today over in the Cincinnati area, different areas of the company working on some outages over there. But here, in this industry, there's a term called flag, tag, and ground. There's also a term called lockout, tag out. Basically the same thing, but in our industry, it's called flag, tag, and ground. There's 4 things that must take place before a line or a conductor can be worked as de-energized. Number 1 is a visible opening. We got to have a visible opening between the work location and the source. So that's what they did here. They take the reclosers offline. The second thing we do is test the line. We test it for absence of voltage. We're looking for 0. So Willis is getting his phasing sticks here. They're going to check, make sure there's no voltage on the line. And the third thing we do is ground the line. Then the last thing we do is flag and tag. So those 4 things, in that order, in my opinion, are very, very important. That visible opening, I got to make sure I have an air gap between the work location and the source, make sure I test the line, make sure there's no voltage. I could have backfeed from a generator. You know, Ron mentioned generators earlier. Basically here, just in a few moments, we're going to show you what backfeed is. We're going to demonstrate backfeed. So I want to make sure there's no backfeed. Number 3, I'm going to ground that line. Number 4, I'm going to flag and tag. Good. Go ahead and flag and tag it. It takes a while, you know, if you think about it, it's taken utilities and co-ops a number of years to build their system, right? One storm come through like in 09, Marty, and wipe everything out. It takes a long time to build it back. And you got to build it back safely. So flag, tag, and ground is one of those safety features that we have to do. We have to do it right every time. In other words, once this line is flag, tagged, and grounded, we've taken ownership of that line. That line belongs to us now, and nobody can come in there and work and re-energize that line unless they talk to one of these guys here first. So just normally go on the neutral first. Always go to your neutral first. Always make sure your grounds are good and tight, good and clean. Then we flag our grounds, and we also would tag our recloser out. That's just an example of single phase flag tagging ground. All right. Okay, that's the end of our low voltage. What we're going to do next is swap everything over to high voltage. And while they're doing that, I'm going to talk to you about backfeed, particularly generator backfeed. Now, I would imagine just about everybody in the state of Missouri has access probably to a generator of some sort, right? You know, especially if they're expecting outages. You know, I've got one at home. I haven't never used it first time. Never had to use it, but I got one just in case. It's got to be used correctly. Unfortunately, the general public may not know exactly how to hook these things up, right? They bring it home, and this has happened before. Matter of fact, we got pictures of one that the customer just brought it home and plugged it right into his receptacle. So what was he doing to his whole house? He was backfeeding everything through his house through one receptacle. Also, it was backfeeding out onto the line, out to where the transformer is. Now, a transformer can do two things. This transformer to our right and to the left can do two things. It can step voltage down, but it also can step voltage up. If you think about how electricity is generated, by the time it gets to our homes, it's been stepped up to that transmission voltage. After it leaves the generation station, it hits these tie yards, and it may be stepped down again to a different transmission voltage. It leaves there and goes to substations. It hits the substations. It's stepped down to distribution voltage. It leaves there and goes to our homes and hits these transformers, and it steps it down again. But that transformer, and exactly what we did right here, we've taken that lead and moved it over to the top. So now we're going to be using that same voltage, and we're going to backfeed that transformer, and we should be able to get around 7,000 volts or a little bit more. Before they get on the truck, because we swapped over to primary voltage, we're going to check the truck, make sure there's no bleed over on our grounds. Sure everything's good. You guys ready?
Ready.
Zero. Another qualification of an electrical worker, after you distinguish exposed live parts, you must determine the nominal voltage of those exposed live parts. So one way you can do that is use a voltmeter like we're using right now. This is called a phasing stick. It can read phase to phase voltage, but also can read phase to ground voltage. So that gives me a great idea. That tells me exactly what my voltage is that I'm working on. So we're going to give you that reading right now. You ready?
Ready.
Coming hot. 6,900 volts. A few moments ago, we was at 120, 240. Now we're at 6,900 volts just because we moved that lead. So now that transformer is backfeeding, just like that generator. You guys that work on the line crew, I know you guys know this. You hear it all the time, especially during storms. Always keep your ears open. Make sure you hear that generator. Figure out where it's coming from. Make sure that it's isolated between you and your work location. What else causes outages? I don't know if you call this a tree or not. Maybe some parts of the state, this is a big tree. This is the tallest tree we could find around here. But trees can cause outages, right? Trees are nice to look at. But during a storm, a tree can lay across a power line and can remain energized. Matter of fact, during '96, we had a big ice storm come through the Carolinas, and we pulled up out there one night on the job, and there's a tree laying across a three-phase. We pull up and get out of the trucks. This guy comes out of the house and he says, "Hey, that's energized up there." I said, "Well, how do you know that?" He said, "Because that chainsaw belongs to me." He said, "I tried to cut that tree off earlier this afternoon and it was energized." He said, "My power's out." I said, "Yeah, your power's out, but that one phase of that 3-phase was still energized. The phase that he was on was out, of course." The public doesn't know the dangers of trees when it comes to power lines. We're going to show you what happens when a tree makes contact. You got a lot of ground, but you got a lot of potential coming from the top down to the earth, where the person's going to be standing there with the chainsaw trying to get that tree off the line. Guys, ready? Coming hot. Now watch the bottom. That arc you just saw right there is about 35,000 degrees and 1/6 of a second. Now watch the bottom. This is where the person can be standing. Ready? Very deadly, very deadly. We tell our guys all the time, leave the tree work to the professionals. You got all these professional tree companies out there, but it's our job during the storm to make sure they're safe as well. We're going to make sure that line is de-energized and grounded before they attempt to remove a tree off the line. Just to prove our point how conductive a tree can be, we've taken the tree limb off of this same tree right here. We're going to take the cutout open there, remove the barrel, like Jeff's doing right now. We're going to take a small tree limb and we're going to bridge that cutout and see if we can get that light to burn. Ready, Jeff? Ready. Coming hot. See our lights out? Lights on. Take it off, Jeff. Back on one more time. Just that small tree limb has enough conductor in it to pick up the coils of that transformer and energize that light. Doesn't take a whole lot, does it? So if that little tree limb and that small tree is conductive, imagine what a big tree, how conductive that tree can be as well. So let's make sure we stress that with the public as well when we're out there talking with them during storms. So the antenna. Now, I'm going to tell my age just a little bit. I can tell my age now. I just became a grandpa 2 weeks ago, so I can tell my age now. Well, I won't tell you my age. You can guess it. But I remember when there were TV antennas. How many remembers those days? Now everybody's telling their age now. There were CB antennas, TV antennas. I remember growing up, getting off the school bus and running home and turning the television on. And I think we got 3 channels at the time, depending on the weather. Go outside and you turn that antenna to get it lined up with the signal. Nowadays we have satellite, direct TV and all that good stuff, cable. I ain't got to worry about that. But I remember in the day, a lot of people were getting hurt putting up TV antennas. Matter of fact, a couple of stories I like to share here. There was a Boy Scout jamboree taking place in Virginia. A couple of days before all the scouts got there, there was supposed to be about 40,000 scouts there showing up. 4 or 5 days before they got there, all the scout leaders met to set up these big tents. And as they were setting these tents up, they were standing these big, tall steel poles up. And 3 of them had a hold of a pole and it became energized. They didn't see the power line up there. There were 3 fatalities. Another sad story, a news crew pulls up to an accident scene. They're inside of a van. There's 3 of them: the driver, the camera person, and there was an anchor lady in there as well. They have a device in there they can raise their antenna from the inside of the van, so they didn't have to get out to raise their antenna. Well, they raised it up into an energized line. They didn't see it. The lady steps out, fatality. She falls over, dead. Their step potential. We'll talk about step potential here just in a second. Exactly what step potential is. In other words, the area around that van was energized. They didn't know it. So this antenna could be anything around our house, on our job site, our ladders, or you guys that work on the fire department have the aluminum ladders. I'm certain you do. Could be anything like that that's conductor. Same analogy as the tree. We're going to show you at the top, then we're going to show you at the bottom. You ready? Ready. Coming hot. Now again, watch the bottom. Again, 35,000 degrees and 1/6 of a second. When we talk about step potential, when a line becomes energized, when it goes to ground, let's say a 7,000 volt line becomes energized at this point right here. At that point where it hits the earth, you're going to have probably full voltage. You may have 7,200 volts there. But one distance away, like a step, what's happening to that voltage? It's wanting to dissipate out into the earth. It's trying to go away. So it could be 7,200 volts here, one step away, it could be 5,000 volts. Those differences of potential by that one step is deadly. It's like taking a rock and throwing into a pond. Well, that rock makes contact, all those ripples you see, that's step potential, basically. So always keep in mind, if you have to get out of a vehicle, you guys that approach vehicles that have hidden power poles and there's lines laying on the ground, there's potential for that whole surface of that area to be energized. And you guys probably don't know that it's energized. There's nothing you can look at unless you see sparks and things of that nature. You always got to keep in mind that difference of potential, that one step can be very, very deadly. Always keep that in mind. And we have power lines during storms that break and hang off the pole. You ready, Jeff? Ready. I'm going to energize this for a second. Now what Jeff is holding in his hand right there, if you listen real closely, you can't hear anything. Matter of fact, it looks harmless. Jeff's holding it in the clear. He has control of it. This is hanging off a pole during the storm. Look what happens when I go to move it. Go ahead. We call that a snake in the grass. It's laying there, it looks harmless. That line is still energized. Matter of fact, a power line can fall on the ground and lay in snow and ice. It can lay in sand. It can lay in certain types of soil and still be energized. You don't know that. You always got to make sure that that line is de-energized before we touch it. How many of us have small kids, love to fly kites? You take that kid out in a big open field, and they got that kite going, that wind's blowing, and hopefully it's not this hot. It's one of those cool autumn days, we're out there flying the kite, and the kite's doing real good, and all of a sudden that kite string breaks. What happens to the kite? It goes bye-bye. That little kid's gonna look at mom and dad and say, I need a new kite. A lot of kite string manufacturers have woven the fiber into a kite string to make it just a little bit more strong, keep it from breaking. So we're gonna demonstrate. Jeff has opened the cutout on the transformer. Close your cutout. We're gonna see if we can get the light to burn with using that little kite string. You ready, Jeff? See our lights out? Got lights on. Now, imagine that little kite string has enough conductor in it. What do our linemen use every day out there? Ropes, hand lines. Somebody asked me one time, do they make a non-conductive rope? This is my view on it. You can take it for what it's worth. I say, yeah, there actually is a non-conductive rope. Now listen real carefully now. If that rope is never used for anything, in other words, it's in a box wrapped in plastic, put up on the shelf and it says never used, that rope is probably non-conductive. It's kind of a joke, but once I go to use that rope, what happens to it the first time I use it? It gets dirty, it gets contaminated. That kite string is very conductive. Imagine our ropes, our hand lines, and things of that nature can be very conductive as well. This doesn't say happy birthday on me. Anybody having a birthday today? About the next 12 months, raise your hand. Yeah, I hope so. Hope we all. But these kite strings and these balloons are very conductive. A kid goes to a birthday party, they get these balloons. They tie that same kite string on it. These balloons are nothing more than a real thin aluminum foil, right? They're called Mylar balloon. They're very conductive. We're gonna do the same test on it as well. Jeff, you ready? So always keep in mind when that kid goes to a birthday party, but it's okay to fly that balloon, but don't let them get it 30, 40 feet in the air. You know, keep it no more than maybe 10 feet at the most, you know. Kind of good rule of thumb. Next part of our demonstration, we're going to demonstrate mobile equipment. We have a lot of mobile equipment. You guys got bucket trucks, digger derricks, cranes. We have all that as well at Pike. We've got moving booms, things of that nature. We have a rubber tire on this representing, we're going to show you that rubber tires have no dielectric properties. Matter of fact, they have steel belts inside of them, right? So there's really no protection right there, if you think about it. So we're going to energize this. You're going to see some fire at the top. Also, you should see some fire at the bottom as well. You ready? Ready. Coming hot. So you've seen the fire at the top, you've seen the fire at the bottom. One thing we do at Pike, we're going to ground it. We ground our mobile equipment such as pullers, tensioners, line trucks, digger derricks, mobile cranes, anything that has a metal part that has a continuity back from the tip back down to the ground. We ground that for protection of the employees, not for protection of the equipment, but for protection of the employees that may be working on or near that piece of equipment. Now, one of the rules that we have here at Pike Electric, when that boom's aloft, when that boom's in the air, we stay off that equipment. That's a good rule to live by. You never know when something can happen. A conductor falls across the boom of that truck, that old conductor I mentioned earlier. So we want to make sure we have protection for those employees on the ground as well. So we're going to ground this piece of equipment. We're going to do the same test on it. And we're still going to have fire at the top. I know you want to look at the top, but look at the bottom this time when we get ready here. There we go. Always make sure that connection's good and tight. Now we're going to take it and put it on the system neutral. That system neutral again is your bottom conductor right there. So all metal parts of line trucks, digger derricks, mobile cranes, pullers and tensioners shall be grounded. That's our rule here at Pike Electric. Y'all's rule may be a little different. Some companies barricade their equipment as well. We also do that as well for the most part, especially on our cranes. We have our cranes grounded. So you notice Willis is going to a system neutral there. That's your better ground. We're going to energize this again, do the same test again. Yeah. Willis said he wished it get a little bit hotter. It's not really hot enough for him. So now, I think we're ready. We have our mobile equipment grounded. Now you're going to watch the top. You're going to have fire at the top. Also, I want you to watch the bottom this time. We'll do it a couple different times. But watch the bottom. You ready? Ready. You see any fire at the bottom? We'll do it one more time. So where did it go? I actually call it a myth. A lot of people think that electricity will seek the closest path to ground. Well, that's true, but it's not 100% true. It'll seek all paths to ground, but it will take the very best direct path to ground. In other words, if we could check the bottom of that wheel right there, I would imagine there's a little bit of energy still on that wheel. But we gave it a better path. We took it away from the earth, or took it away from the ground and took it straight back to the earth. So that's the reason we ground. But a ground doesn't work like a dam. A dam holds back that water, right? Keeps that water from going over or keeps it back. When we ground the line, it doesn't work that way. There's still some energy that can get past those grounds. We ground, so hopefully whatever becomes energized, those grounds are going to cause it to trip. Whether it's a breaker, a recloser, a fuse tap, or whatever it is, it's going to hopefully trip that or blow that fuse. But think about how those grounds are installed. I'm talking to the lineman now. We got to make sure that surface contact is clean, those grounds are in good condition, and that connection is very tight as we can get it. Because we're trying to stop that energy. Now, it's not going to stop all that energy. There's still going to be a little bit get past it. Depends on how tight those grounds are. This part of our demonstration, we're going to talk about human contact. Here you go, Jeff. Now, we talked a lot about different things in the last few minutes. I want everybody's attention. I know you've been paying attention. I know it's real hot here, but to me, this is the most important part of our demonstration. If you don't remember anything today, remember what you see here just in a few minutes. Now, I'm a firm believer. I've been in this industry for 33 years. A lot of years of experience here at the co-op as well. And I'm a firm believer that this industry is a safe industry. It's not dangerous. You heard me say that earlier. We can put the danger into it. Anytime there's electrical contact involving a lineman, there's a breakdown somewhere between a work plan, like Ron mentioned, our lack of planning, our lack of observation, our I guess lack of thinking, and our lack of being prepared. In other words, we left some type of barrier out, whether it's PPE. Now this hot dog, does anybody know what hot dogs are made out of? If we did, we probably wouldn't eat them, right? But if you think about what's inside of a hot dog, there's a lot of water content, a lot of fat content, similar to what's inside of our bodies. A human being has less than 500 ohms of resistance, typically inside his body, or his or her body. On the outside, they tell me an average 6 foot tall, good looking guy like Jeff has less than 1,200 ohms of resistance on the outside of his body. So the human body is a great conductor. Anytime we're talking about electrical contacts, first thing we look at, where was the barrier? Where was the PPE? Where was the plan, Ron? Look what happens when human body makes contact. Ready? Now, anytime a person has electrical contact, there's two things we're looking for, that the doctor is looking for, is an entry and an exit wound, right? The entry wound sometimes may be not as easy to spot, but that exit wound is always easy to spot. The analogy of a shotgun coming out of your body is basically what that looks like. And a person who has electrical contact can burn up to 3 days on the inside. He's laying in a burn, him or her is laying in a burn center somewhere, not knowing if they're going to make it or not. And if they do survive, statistics say that that person's life has been shortened by X number of years. So electrical contacts, to me, should never be happening inside this industry that we're working. We have all the tools and equipment. Here's one right here, but again, we all have one thing in common. What's that? We're all human. We make mistakes. We can miss things. This rubber glove has a hole in it. What are we supposed to do with our rubber gloves every day before we use them? 2 types of tests. By the OSHA standard, you can go above and beyond that. You got to do a visual test and an air test. Make sure there's no holes in it. This rubber glove has a pinhole in it. We forgot to check it. This lineman's going to go use it that day. Look what happens. Ready? A little pinhole at the top. Didn't take very long for that 6,900 volts to find there. These rubber gloves by OSHA standards are tested dielectrically only twice a year. So where do these gloves spend most of the time? In the hands of that lineman, right? They belong to me. Matter of fact, they're called personal protective equipment. They're personal. If I go out and see a crew and they got rubber gloves laying on the dash or out of the glove bag, that throws up a red flag to me. How important is that safety to that person? You know, if these rubber gloves are not on their hands, they should be stored properly and keep them having damage and things of that nature. Hey, I appreciate the firemen being here today. They have a tough job. Matter of fact, I was telling the gentleman earlier, they're the only ones that are running into a building and everybody else is running out when that building's on fire. Now, to me, this industry that I work in is not dangerous. Now, what they do for a living, to me, is very dangerous. I don't know how to control a fire. I can try stomping it out. I don't think that's going to work. They know, they got the equipment, they got the knowledge, the training. So to them, that fire, yeah, it's dangerous. It looks dangerous to us, but to them, they control it. They can control that fire. Now, I know fires get hot, and there's a lot of dangers in fighting a fire. But they have turnout gear. You can call it PPE for them, I guess. They got their coats, their jackets, or the pants, or their breathing apparatus and all this good stuff. But they also have these fireman boots. Now, what's inside of a fireman's boot between the bottom of that boot and the foot of that fireman? Most firemen's boots have a steel shank, correct? That steel shank is there for obvious reasons, right? You know, for protection from cuts and nails and things of that nature. This is an old fireman's boot. I don't know how old it is. We've been using it a long time. Look what happens when a fireman's boot makes contact. Ready? Ready. I pick it up out of there like, ready? I'm hot. So that boot has no dielectric properties. We got to understand that. All PPE, personal protective equipment, has one thing in common. Has a lot of things in common, but one thing in particular has limitations. This hard hat, these rubber gloves, FR clothing, everything I have on is personal protective equipment, but it has a limitation. I got to know what that limitation is. I got to know how to inspect it. I got to know when to use it, how to put it on, things of that nature. So that's the end of our live line demonstration. I know it's been real hot and you folks have been very attentive and I appreciate that. So I'm going to end it with this. Whatever you saw here today, please don't go out there and try to duplicate that out in the field. I know you won't do that. I just got to throw that out there. What you've seen here today is in a controlled environment. But I want to leave you also with this. This industry that we work in can be a safe industry. Talk to some of these old fellows that have been around a long time. I'm one of them now. And we can tell you exactly how to make a living doing this industry, you know, inside this industry for a number of years and leave it just like you came into it with all your fingers and toes and everything else. But thanks again to SEMO for having us here today. Appreciate it. Thank you.